everyone. I am Dr.B.Krishnaveni, Assistant Professor, Department of Mathematics, Aditya University. Today we are going to discuss about Taylor series. So at the end of this lecture, student will be able to use a Taylor series to approximate a wide range of functions around the given point, understanding the accuracy of approximation depending on the number of terms of used. So introduction to Taylor series. Taylor's theorem is a fundamental concept in calculus that provides an approximation of a function as a sum of its derivatives at a particular point. So here it gives an approximation of a function. In what way? As a sum of derivatives at a particular point. It is particularly useful in engineering for approximating complex functions with polynomials, which are easier to work with analytically and computationally. So this gives the introduction of Taylor's theorem. So now let's discuss about what is Taylor's theorem. If f max closed a comma b to R is such that f n minus 1 derivative is continuous and closed a comma b, n minus derivative of f is a derivable and open a comma b, or f nth derivative exists on open a comma b and p belongs to z plus, then there exists a point c belongs to open a comma b such that f of b is equal to f of a plus b minus a by 1 factorial f dash a plus b minus a whole square by 2 factorial into f double dash a plus so on plus b minus a whole power n minus 1 by n minus 1 factorial f n minus 1 derivative of a plus Rn. Here what is Rn is a reminder, and that is given by b minus a whole power p, b minus a whole power n minus p divided by n minus 1 factorial into p into fnth derivative of c. So in this we need to discuss about Lagrange's form of reminder. For that we need to substitute p is equal to n in the above, and we got Rn is equal to b minus a whole power n by n factorial into fnth derivative of c, and this Rn representing Lagrange's form of reminder. Next is Maclaurin's theorem. It is also a Taylor's theorem with the interval 0 comma x to R. So in the above theorem, if you do this, we will get the Maclaurin series, that is f map 0 to x to R is such that n minus 1 derivative is continuous in closed 0 comma x, n minus 1 derivative of f is derivable on open 0 comma x, or nth derivative of x exists on open 0 comma x and p belongs to z plus, then there exists theta belongs to open 0 comma 1 such that f of x is equal to f of 0 plus x by 1 factor into f dash is 0 plus x square by 2 factor into f double dash is 0 plus so on plus x power n minus 1 by n minus 1 factorial f n minus 1 derivative of 0 plus x power n into 1 minus theta whole power n minus p divided by p into n minus 1 factorial fnth derivative of theta x. The last term gives the remainder. And to get Lagrange's form of remainder, we again substitute p is equal to n. Then Rn is given by x power n by n factorial into fnth derivative of theta x. So this was about the Taylor series and the Maclaurin series. So now from that we will get what is the Taylor series expansion and Maclaurin series expansion. The Taylor series expansion in powers of x minus a, or we can say that about the point x is equal to a is given by f of x is equal to f of a plus x minus a by 1 factor into f dash a plus x minus a whole square by 2 factor into f double dash a plus so on. This gives the Taylor series expansion, and from that we will get a Maclaurin series by taking a is equal to 0 in the above. That means we will get the series at the in powers of x. We can say this will be the series of f of x in powers of x, or else about x is equal to 0, and is given by f of x is equal to f of 0 plus x by 1 factor into f dash is 0 plus x square by 2 factor into f double dash is 0 plus so on. So the above is at x is equal to a means it is a Taylor series expansion, and at about x is equal to 0 giving the Maclaurin series expansion. Now let us discuss the question on this. Obtain the Taylor series expansion of sin x in powers of x minus pi by 4. In the powers of x minus pi by 4 means clearly here what is a is equal to pi by 4. So hence we have to take Taylor series expansion. So whether we are getting a Taylor series or the Maclaurin series in the question, we will write the series depends upon that x, that is a value. That means either they may give in the powers of x or in the powers of x minus a. Depends on this, we will select either Taylor series or Maclaurin series. So, and we know what is Taylor series expansion of powers of x minus a, because in this question x minus pi by 4 we need, that is x minus a form. So, hence the Taylor series for that given by f of x is equal to f of a plus x minus a by 1 factor into f dash a plus x minus a whole square by 2 factor into f double dash a plus so on. And clearly here x, that is a is equal to pi by 4. First find out f of x, and the given f of x is sin x. What is f dash x is cos x, f double dash x cos x derivative minus sin x, f triple dash x minus sin x derivative is cos x, f fourth derivative of x minus cos x derivative is minus sin x, minus into minus is plus. Now find out the value of each at x is equal to pi by 4, f of pi by 4, sin pi by 4 1 by root 2, f dash of pi by 4 cos pi by 4 1 by root 2, f double dash x minus sin pi by 4 minus 1 by root 2, f triple dash pi by 4 minus cos pi by 4 minus 1 by root 2, and sin pi by 4 here it is, that is 1 by root 2, so on. So now substitute all the values in the Taylor series expansion. Then we got sin x is equal to 1 by root 2 plus x minus pi by 4 by 1 factor into 1 by root 2 minus x minus pi by 4 whole square by 2 factor into 1 by root 2 minus x minus pi by 4 whole cube by 3 factor into 1 by root 2 plus x minus pi by 4 whole to the power of 4 by 4 factor into 1 by root 2 plus so on. So in every term we are getting 1 by root 2 common, you can take the common 1 by root 2 and you are left with 1 plus x minus pi by 4 by 1 factorial minus x minus pi by 4 whole square by 2 factorial minus x minus pi by 4 whole cube by 3 factorial plus x minus pi by 4 whole to the power of 4 by 4 factorial plus so on. So this gives the Taylor series expansion for the given function in powers of x minus pi by 4. So the next question is finding Taylor series expansion of f of x is equal to cos x about x is equal to pi by 3. Again we got a value here, that is pi by 3, hence take the Taylor series expansion, and in that x, that is a is equal to pi by 3, and take f of x, find out its derivatives. F of x is cos x here, f dash x is minus sin x, f double dash x is minus cos x, f triple dash x minus of minus sin x is sin x, f fourth derivative of x, sin x derivative is cos x. So now put x value pi by 3 in each, we got 1 by 2, that is f of pi by 3, 1 by 2, f dash of pi by 3, f dash of pi by 3 is minus sin pi by 3 which is minus root 3 by 2 it is, f double dash of pi by 3, that is minus cos pi by 3, that is minus 1 by 2, f triple dash of pi by 3, sin of pi by 3, that is root 3 by 2, f fourth derivative of pi by 3, that is cos pi by 3 which is equal to 1 by 2, so on. So now substitute every values in the series. Then we got cos x is equal to 1 by 2 minus x minus pi by 3 by 1 factor into root 3 by 2 minus x minus pi by 3 whole square by 2 factor into 1 by 2 plus x minus pi by 3 whole cube by 3 factor into root 3 by 2 plus x minus pi by 3 whole to the power of 4 by 4 factorial into 1 by 2 plus so on. So now if you see each term we have 1 by 2 common, so hence take 1 by 2 common, and the resultant series is 1 minus root 3 into x minus pi by 3 by 1 factorial minus x minus pi by 3 whole square by 2 factorial plus root 3 into x minus pi by 3 whole cube by 3 factorial plus x minus pi by 3 whole power 4 by 4 factorial plus so on. So now next question is obtain Maclaurin series for the function e power x. So and we know that Maclaurin series expansion of f of x is given by f of x is equal to f of 0 plus x by 1 factor into f dash 0 plus x square by 2 factor into f double dash 0 plus x cube by 3 factor into f triple dash 0 plus x power 4 by 4 factor into f fourth derivative of 0 plus so on. So here given f of x is e power x, f dash x e power x, f double dash e power x, f triple dash e power x, and f fourth derivative of x is also e power x. So now substituting x is equal to 0 in each function, then we got f of 0, f dash is 0, f double dash is 0, f triple dash 0, f fourth derivative of 0, all are equal to 1. Substituting in the above series, we got f of x, that is e power x is equal to f of 0 is a 1 plus x by 1 factorial into 1 plus x square by 2 factor into 1 plus x cube by 3 factor into 1 plus x power 4 by 4 factor into 1, which gives the final series in this way, that is e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial plus so on. So this gives the Maclaurin series expansion of a given function e power x. Now expansion sin x about origin means nothing but Maclaurin series, and here f of x is sin x, and we know this is the Maclaurin series in which we take the values f of 0, f dash 0, f double dash 0, so on. And taking f of x is equal to sin x, find out f dash x, f double dash x, f triple dash x, f fourth derivative of x, substitute x is equal to 0 in each case, and substitute in the expansion, you got the expansion is sin x is equal to x by 1 factorial minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus so on, which is the sin x expansion gives by means of Maclaurin series. Now the next question is finding Taylor's theorem for f of x is equal to 1 minus x whole power 5 by 2 with Lagrange's form of remainder up to 2 terms in the interval close 0, 1. So here consider f of x is equal to, that is 1 minus x whole power 5 by 2 in the given interval close 0, 1. So clearly both f of x and f dash x are continuous. Similarly, f double dash x is derivable in open interval 0, 1. Satisfying the conditions of Taylor's theorem and the Taylor series theorem given by, so since here the interval is 0, 1, the Taylor's theorem expansion becomes f of x is equal to f of 0 plus x by 1 factor into f dash 0 plus x square by 2 factorial into f double dash theta x with the 0 less than theta less than 1. So here you need to find out the Taylor's theorem with Lagrange's form of remainder up to 2 terms. So here 2 terms plus remainder. So now if you take n is equal to p is equal to 2 and a is 0 and x is equal to 1 and take f of x, find out f dash is 0, f dash x, find f dash is 0, that is minus 5 by 2. Next f double dash x, so do the derivative of the previous, finding the derivative of this, we got f double dash x which is 15 by 4 into 1 minus x whole power 1 by 2. And for this we need f double dash of theta x, so which is equal to 15 by 4 into 1 minus theta power 1 by 2. And already we know f of 1 is equal to 0. So hence from that we got f of x is equal to f of 0 plus x by 1 factor into f dash is 0 plus x square by 2 factor into f double dash of theta x. Substituting the above values, you got f of 1, that is 0 is equal to 1 plus 1 into minus 5 by 2 plus 1 square by 2 factor into 15 by 4 into 1 minus theta whole power 1 by 2. And simplify this to find out theta value, and you got theta is equal to 0.36 and is exactly in between 0 and 1. Hence the Taylor's theorem is verified. The question is verify Taylor's theorem. So that's what we check the conditions with Lagrange's form of remainder up to 2 terms, and finally we calculated theta value that should lies in the open interval. Here it is, hence we say that it is verified. And the next question is, using Taylor's theorem we have to show this inequality, that is x minus x cube by 3 less than or equal to sin x less than or equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial for x greater than or equal to 0. So the first case, suppose x is equal to 0 means the x minus x cube by 3 factorial becomes a 0 and this sin x becomes a 0 and this part is also becomes a 0. So hence all three are equal for x is equal to 0. Now let us consider case 2, which is x greater than 0. Since here x is greater than or equal to 0, that's what we have verified already for x is equal to 0. Now let us move for x greater than 0 and take f of x is equal to sin x for every x belongs to 0, t. Now clearly fn minus is continuous in closed 0, t, and nth derivative of s is a derivable on open 0 comma t. Hence, the Taylor's theorem with Lagrange's form of remainder, after 3 steps, there exists theta belongs to 0 comma 1 such that f of x is equal to f of 0 plus x by 1 factor into f dash is 0 plus x square by 2 factor into f double dash is 0 plus x cube by 3 factor into f double dash theta x. So now find out f dash x, f double dash x, f triple dash x and corresponding values, and substitute in the series. We got sin x is equal to sin 0 plus x cos 0 plus x square by 2 factor into minus sin 0 plus x cube by 3 factor into minus cos theta x. So from this, what you got, sin x is equal to x minus x cube by 3 factor into cos theta x. It is ultimately greater than or equal to x minus x cube by 3 factorial. Similarly, by using Taylor's theorem with Lagrange's form of remainder after 5 steps, we got sin x is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial into cos theta x lesser equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial. So, by taking all this into consideration, finally we got the inequality x minus x cube by 3 factorial less than equal to sin x, and which less than equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial. Showed the inequality. So, hence, in this lecture, we come to know how to apply Taylor's and Maclaurin's series. Thank you.